Thank you everyone for coming to this talk. So as Catherine said, I'm presenting work today that's under review at the American Society of Engineering Education Conference. And this is entitled Advancing a Model of Student Intentional Persistence in Machine Learning and Artificial Intelligence. And this work was done in collaboration with Dr. James McGarrion from the MIT School of Engineering, and also Catherine herself and Dr. Allison Oliowski from Ready Lab in the Mechanical and Industrial Engineering Department of the University of Toronto. So I don't have to sit here and tell you why it's important that we have diverse teams in machine learning and artificial intelligence. We've already seen numerous examples where algorithms perform poorly on one group or exhibit bias towards different populations. For example, we have the ProPublica article that exposed that the Compass recidivism algorithm had bias against Black offenders. We've seen that Amazon and their auto resume reviewing algorithm showed bias against women, even when gender cues were removed from resumes. We've seen that commercial facial recognition software works much better on white men than it does on Black women. There's a bunch of examples of Google bias in Google search results. One example being if you search CEO, a bunch of white men come up. And then we've also seen examples where really important algorithms that make important decisions about people's lives, such as who is eligible for enhanced healthcare programs, exhibit racial bias as well. So some suggest that having diverse algorithm design teams may assist with this issue. For example, bringing diverse skills and perspectives and experiences to the algorithm design process will allow these problems in the data to be caught earlier on. So some background on machine learning and artificial intelligence in general. The field is rapidly growing. For example, it's estimated that the revenue of the AI field in general will increase 3 times in the next 3 years. And the job title machine learning engineer is currently the 4th fastest growing job title in the US. And then universities and schools are responding to this rapid growth. We've seen a 100% increase in undergraduate machine learning and artificial intelligence courses from 2017 to 2021, and correspondingly a 40% increase in graduate level machine learning and artificial intelligence courses. But this growth is not equal. If we look at gender specifically to start, 18% of AI PhD graduates in North America are women, with globally around 22% of AI professionals identifying as women. In terms of academia, 16% of tenure-track faculty positions in the field of AI are held by women, and more broadly, around 20% of computer science jobs overall are held by women. Moving on to race, there's around a 4% Black representation of AI PhDs and in general technology work sectors. Around 7% of computer jobs are held by Black individuals and 8% by Hispanic individuals. And then specifically looking at Canada, less than 2% of tech workers in Canada identify as Indigenous. So not only does this lack of diversity impact the algorithms that are being designed and the outcomes on certain populations, but it also leaves minorities out of high-paying, influential, and desirable jobs. So the first step in increasing diversity in this field is understanding why students who choose to study machine learning and artificial intelligence later leave the field. So this work was partially motivated by this article here, which was written by Aaron Seck in 2011, entitled Professional Role Confidence and Gendered Persistence in Engineering. And what they did was they measured 2 types of persistence or retention. So one is the intention to persist, so whether you intend to remain in engineering at some point in the future. And then they also followed these students for 4 years and measured at the end of their degree whether they had remained in engineering, whether they had left engineering but were in a different STEM field, or whether they left STEM altogether. And they introduced a really important measure in this work, which is professional role confidence. And professional role confidence is comprised of 2 parts: expertise confidence, which is confidence in the skills and abilities needed to succeed in a profession, and also career fit confidence, which is the degree to which day-to-day work and values of a profession align with the beliefs of the individual. And specifically, they found that women's low confidence in these areas is a driver of the gender gap in engineering. So that's just one example of a study of persistence in engineering, or STEM more broadly, but there's a ton of this research out there. A lot of researchers are working on persistence and retention in engineering and STEM. So what exactly makes machine learning and artificial intelligence different from these studies that we already know exist, and why are we doing this work again? Well, I think that there's four reasons that, four characteristics of machine learning and artificial intelligence that make it different from engineering and STEM in general. And the first being the requirement for programming skills. So while programming is expanding and moving into a lot more disciplines and more areas of our lives, there are still many roles and even entire disciplines within engineering or STEM that you can go into if you don't want to have to learn to program, or that's something you're not interested in, or you feel you don't have the skills for. Whereas in machine learning and artificial intelligence, the majority of roles, the overwhelming majority, are going to require that you have some knowledge and some understanding of programming. The next is the varying emphasis on non-technical skills. So whereas in some engineering and STEM fields, it's very clear whether your non-technical skills are very important or not that important, in machine learning and artificial intelligence, it can vary. For example, there are some job postings that you can look at in machine learning and artificial intelligence that detail all of the technical skills you need, all the languages you need to know, all the models you need to know how to use, and have almost no mention of any interpersonal or non-technical skills. And on the other hand, there's a lot of data science roles that talk about your technical skills needed, but also really emphasize the ability to communicate technical concepts to non-technical people and work as part of a team. Next, there's still ambiguous ethical implications of machine learning and AI. So if we take engineering as a counterfactual example, engineering in general has the stereotype that if you go into engineering, you're going to be doing something that is good for the world, you're going to have a positive benefit on society. Whereas AI sometimes can be portrayed in the media as robots that are going to take over the world, and it can have a negative connotation attached to it. Although we do know that there are a lot of people in the world who are using machine learning algorithms in ways that have a very positive benefit on society, such as detecting images of cancer tumors in MRI images. And lastly, we are in this kind of machine learning bubble right now. So it's in very high demand, it's still competitive to get into. You need to have, everyone's trying to get into it. If you do get into the field, you can make a lot of money. It's very lucrative. So it's kind of a very in the moment career right now. So I'm going to overview the first iteration of this work. So this isn't the first time that our lab has done this study. It was actually done the first time in 2020 by Kimberly Wren and Dr. Allison Oliewski, and it was published in the American Society of Engineering Education again. And it was pretty well received, and it received a lot of attention, which sent the message that both the education field and the machine learning and artificial intelligence field are interested in this type of work. They believe it's important to promote diversity and study the retention of students in this developing field. And specifically, this work looked at intentional persistence, comparing intentional persistence in machine learning and artificial intelligence to persistence in engineering. And they studied a multitude of different independent variables, one being the professional role confidence measures that I just overviewed that were outlined by Sec al. They looked at technical confidence, so the confidence in your technical skills. They looked at students' experiences of discrimination, how long ago they were exposed to machine learning and artificial intelligence as a career, their social benefit interests, so how important it is that your work has a positive benefit on society, and also how competitive the students were. And this work found that women, compared to their peers, experienced more discrimination, and they also had lower levels of technical confidence. In terms of persistence in machine learning and artificial intelligence, they found that intentional persistence was positively associated with being a woman, with having high levels of professional role confidence, and also being competitive. And they found that it was negatively associated with having high levels of social benefit interests, so wanting your work to have a positive benefit on society, also negatively associated with being a woman and a visible minority, and being a woman and experiencing discrimination. So how is this study any different? Well, our goal is to expand on that first study that I overviewed and advance the model and advance our understanding of student intentional persistence in machine learning and artificial intelligence. So we're examining new independent variables in this work. Specifically, we're focusing on gender again, because gender is a demographic variable that we're likely to have large enough sample sizes in groups to make statistically significant claims about, but I do cover other demographic variables later in the presentation. We're also focusing on social benefit interests, so again, how important it is that your work has a positive influence on society. We're looking at non-technical skills this time instead of technical skills, and also a new measure of social belonging. And our settings, so we surveyed 165 students at the University of Toronto in fall of 2021, and these were students who are currently enrolled in a machine learning or artificial intelligence course. So I've been using a lot of terms already, but now I'm going to get into the nitty-gritty and define these for you. So persistence is a commitment to remain in a profession or a field. And in the literature, there's generally two types of persistence that you can measure. The first being intentional persistence, so whether or not someone intends to remain in a field or a profession at some point in the future. And then there's also behavioral persistence, which is whether someone actually remains in that field if you follow them, whether they're still there at some point in the future. But for most of this presentation, I'm going to be focusing on intentional persistence, although I will touch on behavioral persistence at the end. And we measured intentional persistence in two different ways. The first being short-term intentional persistence, which is the answer to the question, what is the likelihood that you'll take another machine learning or artificial intelligence course in university? And we also have long-term intentional persistence. So what is the likelihood that you will be in a machine learning or artificial intelligence role, either academia or industry, in 5 years? And this was the question that's similar across past persistence studies. So now I'm going to move into the variables that we hypothesized about, the first one being social benefit interests. And that's defined as the feeling that your work has a positive impact on society. And in the past, this has been shown to be important for persistence and retention work, but also more generally job satisfaction. Research has shown that women are more likely to explain their interest in engineering based on the societal contribution that they can make. They're more likely to rate applied and impact-driven work as important in making their career choices. And they're also more likely than their peers to be concerned about the impact of AI. So based on this research, our first hypothesis is that among students, women will have higher levels of social benefit interests. Other research on social benefit interests in machine learning and artificial intelligence has shown that it's still a newly evolving field, and opinions are quite split on whether AI is positively beneficial or not beneficial to society. Specifically in in North American countries and Western European countries, it's pretty much split down the middle. Half of the people believe the development of AI is positive for society, and half of the population believe that it's not positive for society, whereas in some Asian countries, it's more skewed towards a positive view. But in general, reports have found that positive views of AI are held by those who are male, who are wealthy, younger, educated, and have more experience with technology. In a survey of students who are studying machine learning and data science currently, they said that they view data science as both a low impact career and a low purpose career. So given this research, our next hypothesis is that social benefit interests will be negatively associated with long-term intentional persistence. And specifically, we measured social benefit interests using the 3-item altruistic work value scale that was developed by Lyons and team in 2006. The next variable that we hypothesized about is non-technical self-assessment. So although technical skills have been important and included in persistence studies for a very long time, specifically in terms of engineering and math, engineering and STEM, a lot of studies focus on math. But recent research has showed that technical skills might not actually be as critical to persistence as we once thought. So we do still include technical skills in our model, but they're just a part of the expertise confidence measure that I will get into in more detail in a second. But in this work, we're focusing on non-technical skills because they vary in their importance in machine learning and artificial intelligence roles. So again, we can start by looking to engineering as a related field. This is an excerpt of the Engineering Accreditation Board in Canada, and this is the list of their graduate attributes, of which about 4 to 5 of them probably have nothing to do with technical and are completely around non-technical skills. But I just have 2 important ones on the screen here. So one being the ability to work effectively as an individual and as part of a team and being able to lead a team. And then we also have communication skills, which is the ability to communicate complex engineering concepts within the profession and society at large. But if we look specifically at machine learning and artificial intelligence, here I've included a screenshot from a current data scientist role, from DoorDash that's posted right now. And this is the list of qualifications that they ask for. And as you can see, they're overviewing the degree you have to have, the models you have to know how to use, the languages that you have to know how to use, different softwares that you should be able to use. And there's little to no mention of non-technical skills. Whereas comparatively, this is a machine learning engineer posting for Nugget AI, and they have an entire section under their qualifications for people skills that focuses on strong problem solving skills, the ability to take ownership, being a critical thinker, and being able to work in a fast-paced, agile environment. Some additional research on non-technical self-assessment shows that women are generally stereotyped to have stronger non-technical skills than their peers, but this stereotype doesn't always work in their favor. And specifically in engineering, it's been shown that the stereotype of having strong non-technical skills is used to promote women into management and out of technical positions. So based on this research, our first hypothesis is that among students, women will have higher levels of non-technical self-assessment. Other research has showed that if you hold technical skills constant, so in this case, math and science skills, those who have higher skills in reading and writing can actually be a negative predictor of persisting in STEM. And then similarly, if we look specifically at engineering, it was found that wanting to pursue a leadership position post-graduation was a negative predictor of intending to remain in engineering long-term. So based on this research, we have two additional hypotheses. One being that non-technical self-assessment will negatively predict short-term intentional persistence, and that it will also negatively predict long-term intentional persistence. And although non-technical skills is a broad term that can cover a lot of things, we had to scope it down in this study. So we focused specifically on interpersonal skills, which we defined as leadership, teamwork, and communication. The last variable that we hypothesized about is social belonging confidence. So social belonging confidence was a scale that we developed for this work, but social belonging as a concept itself has been used in persistence literature before. And we define social belonging confidence as the degree to which a person feels that they will fit in with the social and cultural aspects of a profession and develop meaningful relationships with their peers. And research has shown that this is similar to stereotype threat, which is the risk of confirming a negative stereotype about your group. So it was found that marginalized groups may have lower confidence in their social belonging. Specifically, women have lower levels of social belonging, which leads to our first hypothesis that among students, men will have higher levels of social belonging confidence. And social belonging was also found to be a positive predictor of intentional persistence in STEM, and it was actually a stronger predictor of persistence than technical confidence, for example. So our next hypothesis is that social belonging confidence will positively predict long-term intentional persistence in machine learning and artificial intelligence. And again, we measured this using a scale that we developed, and it was a 3-item measure that covered your whether you're confident in your ability to find community in the field of machine learning and AI, whether you were confident in your ability to fit into the professional culture in machine learning and artificial intelligence, and whether you're confident in your ability to relate to others in the field. So those are the 3 variables that we hypothesized about in this work, but we did collect a lot of other information from our participants and included that in the model as well. The first category of information being experience with and attitudes towards machine learning and artificial intelligence, starting with those professional role confidence measures that I talked about before. To define those concretely, career fit confidence is the degree to which the day-to-day work and values of a profession align with the interests and beliefs of the individual. And expertise confidence is a holistic view of one's confidence in having the competency and skills and knowledge required to succeed in a profession. Other than that, we also asked students about their experiences of discrimination or unequal treatment in machine learning and artificial intelligence courses, how long ago they learned about the field as a career option, how important it was that they earn a high salary relative to their peers, how often they participate in competitive pursuits, and whether or not the popularity of machine learning and AI as a subject right now influenced their choice to take the course. And we also collected a bunch of individual characteristics from our participants. So we collected gender, visible minority status, which was measured using the Statistics Canada visible minority question that lists 12 different visible minority options. We asked whether students identified as an international student, so they were not a citizen or permanent resident of Canada, whether they indicated that they or their family had to take out student loans to pay for school, and whether they identified as a first-generation student, so neither of their parents had completed a 4-year university degree. So now to go over how we distributed our survey and who we surveyed specifically. So we did all of our surveying in fall of 2021. And our intention was to do our surveying in person. We wanted to visit these classes in person with paper surveys and have 15 minutes of class time for students to fill out our surveys. But fall of 2021, everything was still a little bit in the air with COVID. So a lot of the classes we wanted to survey were either offered hybrid with some students participating completely online, or were either held completely online themselves. So we did end up getting 65.5% of our sample surveyed in person, but we had to create an equivalent online version of our survey as well, in which 34.5% of our sample came from, in order to reach those students who were taking the courses online. So in terms of who responded to our survey, around 33% of our respondents identified as a woman, with around 61% identifying as a man, the remaining percent identifying as a gender identity outside of woman or man, or they preferred not to respond to the question. In terms of visible minority, there was only 3 groups that we had a large enough sample size of to report. Those being those who identified as Chinese, which is 42% of our sample, those who identified as South Asian, which is 18% of our sample, and those who did not identify with any visible minority, which is 16% of our sample. We surveyed both graduate and undergraduate courses, so around 43% of our final sample were graduate students. Around 58% indicated that they were enrolled in a machine learning or AI program component of some sort. So that could be a major, a minor, a certificate, a stream that they were in, or a specialization. And then in terms of other demographic variables, 44% of our sample identified as an international student, 13% identified as a first-generation student, and 33% identified that they had student loans. So moving on to our analysis process. To analyze this data, we built 2 logistic regression models, one for each of our dependent variables. So one predicting short-term intentional persistence, whether or not students identified that they would intend to take another machine learning and AI course in university, and then one for long-term intentional persistence. So whether students intend to remain in the field in 5 years. And both of these models followed the same analysis process. So the first model that we built was just gender and controls, with controls being that whole slide I had of other independent variables, so non-hypothesized variables. And then we built our second model, which we just took model 1 and added those predictors. So the 3 hypothesized variables that I went into in more detail. And then our last model was model 2 plus interaction effects. And we identified the interaction effects by focusing on gender, and if gender varied significantly with any, or if any of our independent variables varied significantly with gender. So now we're going to move into the fun part, which is what we found. So this slide, I'm just going to, in general, overview the significant predictors for both our short-term intentional persistence and long-term intentional persistence models, but then I'm going to go into more detail in the interesting findings. So in short-term intentional persistence, we found that it was positively associated with being surveyed online, which is a survey control value that I'm going to discuss in more detail later. And it was borderline significantly positively associated with career fit confidence, so high levels of career fit confidence, being influenced to take the course due to the popularity of the subject, and also being enrolled in some component of an MLAI program. Short-term intentional persistence was negatively associated with being an electrical and computer engineering or computer science student, being a graduate student, and it was borderline significantly associated with being a first-generation student and frequently participating in competitive pursuits. In terms of the long term, we found more significant predictors in this model. So long-term intentional persistence was positively associated with both career fit confidence and expertise confidence, as we would expect, as they were shown to be significant in past work. It was also borderline significantly positively associated with non-technical self-assessment, so having high levels of assessment in your interpersonal skills. Also, whether you had taken a prior course in machine learning and artificial intelligence, and whether you were surveyed online. And it was negatively associated with having high levels of social benefit interests, frequently participating in competitive pursuits, being influenced to take the course due to the popularity of the subject, and being surveyed late in the semester, which is something else I'll get to later. And it was also borderline significantly associated with a toxic environment, but in this case, a non-toxic environment, and also being an electrical and computer engineering or computer science student. So to get into these in more detail, the first variable that we hypothesized about was social benefit interest. And to remind you, we had 2 hypotheses. So the first one being that among students, women will have higher levels of social benefit interest. And the second being that social benefit interest will be negatively associated with long-term intentional persistence. And actually, both of these we found support for in our data. And actually, a decrease of 1 ordinal value on the social benefit interest scale, which was measured on a 5-point Likert scale, results in a 71% increase in odds that the student expects to work in machine learning and artificial intelligence in the future. So those two findings together, that women have higher levels of social benefit interest and that social benefit interest is a negative predictor of intention to remain in machine learning and artificial intelligence, highlight that this might be a potential driver of the gender gap in machine learning and artificial intelligence. And this is important, one, because this finding, or at least the finding that social benefit interest is a negative predictor of long-term intentional persistence, was found in the first iteration of this work too, even though we asked about social benefit interest in two completely different ways. In the first iteration, it was asked with a one-item measure, a single question, and we used a three-item measure here, and we find the same results. So we find that it is robust to the way that we ask about social benefit interest. This finding also echoes many survey reports that have been done recently that show that women are more concerned about AI. And specifically, women are concerned about personal data collection when it comes to AI technologies. And they're also concerned about the loss of human contact that might result from overly using AI technology and AI ending up in more areas of our lives. And this is also empirical evidence of something that was suggested in a paper published in 2018 that stated to get more women into machine learning and computer science more broadly, we need to show how these careers can be meaningful. So implication for educators. One is that machine learning and artificial intelligence educators should highlight the socially beneficial uses of these tools. But obviously, it's very important that we don't paint an overly glossy picture of machine learning and AI and that nothing wrong ever happens with it. We need to equip students with the tools that they need to evaluate the ethics of a machine learning and artificial intelligence project that they might take on. And this should go beyond just technical fixes or just lines of code that you can add to the end to evaluate the fairness of your model. And it should really take a multidisciplinary approach and learn from all of the scholars in different fields that are studying this. Moving on to the next hypothesized variable, which was non-technical self-assessment. We had three hypotheses. It was that among students, women will have higher levels of non-technical self-assessment, and that non-technical self-assessment will negatively predict both short and long-term intentional persistence. So we didn't find support for any of these hypotheses in our data, although so the direction for hypothesis 2B was in the direction we'd expect. It wasn't significant, but it was negative. However, the direction for hypothesis 2C was in the opposite direction. And it actually might look like that having high levels of non-technical self-assessment may be related to a higher intention to remain in machine learning and artificial intelligence in the future, which suggests that in the long term, students might recognize that interpersonal skills may be useful in the workplace, even in a very technical career like machine learning and artificial intelligence. We found that although non-significant, the direction suggests that women may have higher levels of non-technical self-assessment, which leads to the first implication for educators, is that educators should emphasize the importance of these skills in machine learning and artificial intelligence careers. But we also found that students who identified as Chinese actually had significantly lower levels of non-technical self-assessment than their peers, which leads to a second implication that educators should continue to emphasize the development of these interpersonal skills in these courses by designing projects that have teamwork components and leadership components and presentation opportunities. Lastly, so the third hypothesized variable was social belonging confidence. And again, we had two hypotheses around this variable. One, that among students, men will have higher levels of social belonging confidence, and two, being that social belonging confidence will positively predict long-term intentional persistence. And we found support for the first one. So men do have higher levels of social belonging confidence, but we did not find support for the second hypothesis. And actually, the directionality suggests that social belonging confidence may actually be associated with a decreased odds of intending to persist in machine learning. So social belonging confidence is also the focus of Catherine's thesis. So what she's been doing is doing a bunch of interviews with students that we surveyed to learn more about how social belonging impacts persistence. And something that we see is that social belonging confidence might be less important when choosing a career than career fit confidence or expertise confidence and the questions that comprise those measures. As we saw that career fit confidence and expertise confidence were both positive and significant predictors of intentional persistence. And social belonging confidence is really not top of mind for many students when they're thinking about career choices. In the interviews, no students brought up any measure or mention of social belonging confidence on their own, but when prompted, all of them agreed that it is important. But either way, this still warrants a further investigation in our future work, and we hope to study this with a larger sample size next time. Moving on to the unique characteristics of machine learning and artificial intelligence. So what I highlighted what made it different from engineering and STEM more broadly. So first, focusing on the lucrative nature of the field, we found that overall our respondents of our survey responded that it was important to them to earn a high salary, but this importance was not a significant predictor of either long or short-term intentional persistence. In terms of competitive participation, we found that frequently participating in competitive pursuits was actually a negative predictor of long-term intentional persistence. And this is similar to what was found in the first iteration of this work, but specifically they found that being competitive and being a woman was a negative predictor. And we reason that this might be because there is a lot of demand for machine learning professionals right now, and such a high demand may make the field overall seem less competitive. And lastly, moving on to the rapid growth and demand that we see in machine learning and AI right now, we see that this might influence students' course choice, because taking the course due to popularity was a positive predictor of whether they would take a second course, but it was a negative predictor of whether or not they plan to stay in the field long term. So we see that it may impact course choice, but it's probably the popularity of the field is probably not enough to influence their entire career choice. And something that we should keep in mind, both as educators and persistence researchers, is that not everyone right now who's taking these machine learning and AI courses has the intention of doing so because they want to persist in the field, they want to build a career in this area. A lot of times they're taking it because they think it'll look good on their resume or their friends are taking it. So moving on to the toxicity of environment. So this was, I'll get into in a second how we measured this. But the first thing I want to note is this was reverse scored. So students who gave us a high value of toxicity of environment actually were stating that they have a very non-toxic machine learning and artificial intelligence environment. And we found that this was a borderline significant negative predictor of long-term intentional persistence, which is the opposite of what you'd expect, which is basically saying that students who had a highly non-toxic machine learning and artificial intelligence environment were also less likely to intend to persist in the future. So we measured the toxicity of the environment using a 3-item measure. That was during my machine learning and artificial intelligence courses, I've experienced instances of being discriminated against due to my identity, being spoken to differently due to my identity, or having stereotypes of my identity enforced. And we reason that this could be because students who experience discrimination and unequal treatment in university are confident that this won't continue in their careers. So even if they did experience toxic environments in university, they don't believe that this reflects the machine learning and artificial intelligence field as a whole. But another reason could actually be that having negative experiences motivates these students to persist and prove others wrong. By having someone tell them that they can't do it, it makes them want to do it more. But either way, we don't have answers to why this is. So it's something that we're going to revisit in future work. And maybe we would measure this differently next time around. All right, another big finding that we have that both came out of some of the interesting and maybe unexpected findings in our survey results, but was really solidified after hearing some of the comments from Catherine's interviews, is that there are many nuanced identities within machine learning and artificial intelligence. So one, students really vary as to what general career area that they identify machine learning and artificial intelligence with. Some think it's an engineering field, some identify it as a computer science field, others identify it as a field on its own. And they even vary as to how they define machine learning and artificial intelligence. So as you've noticed, we kind of grouped machine learning and AI together in this work, obviously, and we didn't see an issue with that. We were like, yeah, of course, they're the same thing. But hearing some of the interviews, we've noticed that some students think machine learning is a completely different thing than artificial intelligence, and one may be very hard and technical, whereas one might not be so much. But this also varies, and there's no one general consensus of what the difference between the two are. What we also heard in the interviews is that there's a really clear difference for some students between applying a machine learning algorithm versus developing that algorithm themselves. And students differed in whether they believe that just like applying an algorithm that someone else has developed, whether that counts as working in the field of machine learning and artificial intelligence, which would obviously impact the way that they responded to our persistence questions. We also heard that students who are less confident in their programming skills may be interested in the field in general, but not feel that they have the skills to develop these algorithms themselves, and therefore maybe they don't belong in this field. And lastly, interestingly, we found that being in a programming heavy major, so we define that as electrical or computer engineering or computer science, was negatively associated with intentional persistence, as you might have seen on my results summary slide, which suggests that there's a more complex relationship between identity of students, their skills, and intentional persistence in the field, and their understanding of what the field even is. So it's definitely something that we want to investigate in more detail in our next iteration of the study. And this highlights the importance of capturing the persistence in various subgroups of machine learning and AI, which in itself is hard to define what a subgroup of it is. And I don't think there's general consensus on that just yet. And it's also important that we measure where students plan to work. So for students who indicated that they don't plan to stay in the field of machine learning and artificial intelligence, it's important that we understand where they do plan to go. As for example, students in software engineering, if they don't plan to stay in machine learning and artificial intelligence, it's quite possible that's because they plan to go into an equally technical and equally lucrative field of software development, for example. So moving on to individual characteristics of our participants, unfortunately, this work really didn't highlight any interesting relationships between individual characteristics and persistence, but we did some deeper digging into some of our demographic variables, and we have some areas for future work. So for example, visible minority status, those three groups that we had a large enough sample size to analyze were not significant in either our long-term intentional persistence or our short-term intentional persistence model. But when we looked at how these demographic groups responded to some of the other questions in our survey, we found that those who identified as South Asian generally responded that they have higher levels of expertise confidence. And those who identified as Chinese had lower levels of expertise confidence on average and lower levels of non-technical self-assessment. So these are things that we plan to address in future work. Also, in terms of gender, again, it was non-significant in either of our models, but the direction suggests that being a woman may actually be positively associated with intentional persistence in machine learning and artificial intelligence, which matches what was found in the first iteration of this work. And this finding might suggest that the gender gap actually happens somewhere out after university. Maybe it happens in their first job. They intend to enter the field, they do enter the field, and then something happens there. So this is something that we plan to explore more in future work and hopefully in interviews as well. And lastly, another group that we studied were international students. Again, being an international student by itself was not significant in either our long-term or our short-term intentional persistence models. But we did find that international students were special in a couple ways. One, that they learned about machine learning and artificial intelligence more recently than their peers did. And they also had higher levels of social benefit interest than their peers, which we know is a negative predictor of long-term intentional persistence. So this is another group that we plan to address in more detail in future work. So overall, I've gone over some implications for educators already, but I'm going to tie them all together here. The first is that it's important to emphasize the positive benefits that machine learning and AI can have on society, while also teaching students the ethical frameworks and providing them with the tools they need to make sure that they can apply these technologies in a way that aligns with their values. It's also important to emphasize, we should emphasize the importance of and also encourage the development of interpersonal skills in these courses. So for example, you could have a guest speaker who can come in and speak to the importance of interpersonal skills in their role in the field of machine learning and artificial intelligence. And we should also pay attention to who is teaching these courses. So this was something that mostly came out of our interviews. The interviews showed that students who are passionate about persisting in machine learning and artificial intelligence all had a mentor who helped them to build this passion and build the skills that they needed. So we should pay attention to having mentors and people in power in machine learning and AI that share identities with our students. And we should also be aware that not everyone is taking these courses or taking these machine learning and AI courses as a means to a career in machine learning and artificial intelligence. So the group that educators are teaching is probably going to have a wide variety of intentions with the course, and we should teach the course in a way that supports that. Lastly, aside from learning things about machine learning and AI from the results of our survey, we also learned a lot just from the surveying process in itself. The first being that in-person surveys have a much higher response rate than online surveys. To contextualize this, we had around an average of a 90% response rate for our classes that were surveyed in person, and a corresponding 15% response rate for our classes that were surveyed online, which shows that there's a real self-selection bias for our online participants. Those students who went out of their way to click the link in the announcement and go through our survey were probably really passionate about staying in machine learning and artificial intelligence and our study in general, which is definitely why we see that taking our survey online is a significant positive predictor of taking another machine learning and AI course, and a borderline significant predictor of persisting in machine learning and AI long-term. We also included another survey control, which is time of semester surveyed. So although we did our entire surveying through the second half of the semester in fall of 2021, we kind of split it into students who were surveyed in the third quarter and then students who were surveyed at the very end of the semester. And we found that being surveyed late in the semester was a significantly negative predictor of long-term intentional persistence, which suggests that if you survey students at the very end of the semester, you may capture a negative attitude that they have, which could be a result of many things, one being maybe poor grades that they have received at that time, or it could just be a general fatigue that comes with the end of the semester. So in our next iteration of this work, we're going to try to survey students in person, only as much as possible. Hopefully classes will be happening in person, and also survey students hopefully all within 1 week. We'll try and get all of our surveying done. And ideally this week would be somewhere in the middle of the semester so that we can capture students when they still have some understanding of machine learning. They've been through a little bit of the course already, especially if it's their first course, but we also don't pick up on that general fatigue that comes at the end of the semester. And lastly, measuring a variety of gender identities is quite trivial. It's very easy to add more options in your gender question on a survey, but actually incorporating these identities into statistical models is more challenging. And this was something that required a lot of careful thought and a lot of discussion within our team. So a lot of times you'll have groups that are quite small, too small to make statistically significant claims on their own, but you still want to study the bigger groups, and it's not clear if you should combine these students in with other groups. So it's something that requires a lot of careful thought, and we spent a lot of time on in our work. So moving on to our next steps. Right now we're conducting interviews, or actually we just finished conducting interviews, and now we're analyzing these interviews, which are really helpful to give us a lot of context on how students understood our survey, how they responded to our survey, and specifically how social belonging impacts their intent to remain in machine learning and artificial intelligence. And then in the fall of 2022, moving into winter of 2023, we plan to redistribute the survey, and we want to reach more classes and more schools. And we're going to make some changes to the survey before we do that. So we plan to record where students go. So if students indicate that they don't intend to remain in machine learning and artificial intelligence, we want to ask them where they do intend to be. We want to include a measure of technical skill self-assessment, which will be tricky because it does overlap a lot with the expertise confidence measure that we already include. And we're also going to ask about various identities within machine learning and artificial intelligence, which is challenging again on its own, because what those subgroups within it are is not something that's been established already, and students might misunderstand even if we have dedicated groups of these. So those are the challenges we're dealing with right now. And then in 2026, and probably a couple years after that, what we're doing is measuring behavioral persistence. So what we've been doing is, as students respond to our surveys, we have a part at the bottom that asks for their email address and asks if they consent to be contacted again in 5 years, with a very short survey just asking them where they are. So we've collected that for our participants from this last semester, and we're going to continue doing that. And then 5 years after they've been surveyed, we're going to reach out to these students again, collect that information, and hopefully then we'll have a better picture of persistence in machine learning and AI overall, because we'll have both the intention and whether they actually persisted. Which leads to the same shameless self-promotion. So if you or anybody you know is involved in an introductory level machine learning and artificial intelligence course, we would love if you would generously allow us into your class for 15 minutes to survey your students. So we're running the next iteration of the survey in fall of 2022 and winter of 2023. So we're going to work this summer to get ethics approval for different universities if we need it, and plan that. So please contact me if you would be willing to let us survey your students. All right, so in conclusion, what we've done is we've advanced a model of understanding that examines the factors associated with students' intentional persistence in machine learning and artificial intelligence. And when we did that, we found that wanting your work to have a positive social benefit is a negative predictor of students' intent to remain in machine learning and AI in the future. And in general, women care more about this. We also found that having high self-assessment of your interpersonal skills is associated with intending to work in machine learning and artificial intelligence in the long term. So implications for educators is that they should focus on building interpersonal skills and also emphasizing the importance of interpersonal skills. And they should also meaningfully discuss both the social benefits of machine learning and artificial intelligence, but also the potential risks, with a focus on how students can overcome these risks. And quickly, I just want to thank everyone who made this work possible. So to the professors who kindly gave us class time to survey their students, and also to Prachi, who was one of our summer students and last year, and she was very helpful in developing these survey questions. And that's the end of my presentation, and I'm glad to take any questions.